So in this projectile motion problem, I want to figure out how high is the ledge. So I've got some kind of object rolling off at 4 meters per second, and it lands 3 meters away into the water. Okay, so let's start with looking at what we know with the table of givens. So look at our kinematics givens, since this is projectile motion, and I've got two tables actually. One's going to be the vertical column and one's the horizontal column. And so vertically, that's everything that goes up and down. I have the initial velocity is equal to 0 because it's going, whatever this object is, it's traveling horizontally. X is unknown, and the acceleration is due to gravity, so that's going to go downwards, 9.8 meters per second squared. So these are all the givens that I have that are going up and down in the vertical direction. Now I could make downwards instead of being a negative. I could make it a positive number, or all my answers come out positive instead of negative. Either way will work. You just got to be consistent that down is the positive direction here. So horizontally, what do I know? Well, I know that 4 meters per second horizontally, and I know the acceleration is 0 horizontally, which means the final velocity is also 4 meters per second. And whatever this is that went off this ledge, it landed 3 meters away from the edge in the water. So there's my 3 meters. So in reality, my table that I draw on my paper doesn't look so neat. It looks more like this. So this is what my table looks like on my notebook paper. Kind of simple, straightforward, and quick. That's what I want. All right, so what's my strategy for this problem? Well, my strategy is going to be, I got to find the time in the air, but this time I'm going to use the horizontal givens. You've seen the other examples, you see how I use the vertical givens. This time I don't have enough information vertically, so I'm going to use the horizontal givens to find the time. And then once I find the time, I'll use only the vertical givens in this new time to calculate the height. So I'm going to find the time with the horizontal givens. I'll start with the x equals x naught plus v naught t plus 1/2 at squared equation. And when I do this, a lot of things are going to go to 0, so that's going to leave me with x equals vx naught times t. That's the horizontal velocity times the time. Sometimes we refer to this as just the range equation, and we write this as the range is equal to v naught times t. So I'll rearrange this for t. I'll put in my horizontal distance and my horizontal velocity. And then when I find t, I get it to be 3/4, or 0.75 seconds. So that's the time, how much time it takes to hit the water, or travel that 3 meters, which is the same as how much time it takes to hit the water. So I can put those two times in my columns. You can see now I've got a lot of givens in the vertical column to figure out what I need to know. So I'm going to find the ledge's height using only the stuff in the vertical column. So when I talk about x in this case, I'm talking about the height. That's really what it means. So my equation is x equals x naught plus v naught t plus 1/2 at squared. X naught, well, that's always going to be 0 for us. And v naught, it's going to start off also being 0 because it's not going up and it's not going down. Therefore, x is equal to 1/2 at squared. Put in my numbers, including the time I just calculated, and that's x equals negative 9.8 meters per second squared times 0.75 seconds. Solving it for x, I get negative 5.51 meters. In other words, it went downwards, negative 5.51 meters, which is true. So that's the height of the cliff. It's 5.51 meters down to the water.